Hello and welcome to Lab 4 Part 1. In this part, we have set up our ESP32 with a hardware timer with a period of 30 seconds. When the timer fires, we will measure the onboard temperature and Hall sensors and print them out to our terminal here. We will also send that data over to ThingSpeak using Socket API and HTTP GET request, and we have two channels for two fields of our channel set up, one for temperature and one for our Hall sensor. The existing data is from testing it earlier this week. So I'll go ahead and run this. Right now, our ESP32 is trying. Okay, so here we have connected to our home Wi-Fi, apartment 7. And we have our IP address that's been printed out. And we'll wait a little bit. So we got our first temperature reading, which is 53.9 degrees Fahrenheit, and a Hall sensor of 26. And so we see that data point added here. And now the existing data points here have been taken on other days, as you can see at the bottom, 14th of November, 15th of November, and now we're over here on 18th of November. Again, we get the temperature reading of 53.33 degrees Fahrenheit, 25 for our Hall sensor reading, and our ThingSpeak response. Okay, another reading of 53.33 degrees Fahrenheit. And now these are all gonna look really similar over here because they're all relatively the same value. So they're coming in right here. So that dot is going over itself. But over here on the Hall sensor, we see that we got different readings with the 26, the 25, and the 30. So they're piling up over here. We got another reading of 53.89. Again, the temperature is very similar. And the Hall sensor is 27 volts. So we see another data point come up there. We get another reading with 33 volts and 53.33 for Fahrenheit. Again, the temperature is staying very similar over here. So I can actually go in and let's try and make, can we change the axis? I will work on that for my screenshot just so we could see, because our temperature readings are so similar. So they're all like right here. But we see again our Hall sensor data is picking up, and we see that our temperatures are very similar, reading the same over and over again at 53.33 and a new Hall sensor of 26 volts. And we're getting good responses and good readings, consistent readings, which is very good. Again, 32 volts, 53.33 degrees Fahrenheit. And we're seeing the data points pile here, landing at 53.3 there. Okay, we're getting 53.33 and 32 volts. And it concluded. Right at 5 minutes. Okay. Thank you for watching. And have a great day. Hello, I'm Julianne and welcome to Lab 4 Part 2. This is a demo of the espserver.py, and I'll go ahead and click run. So currently our ESP32 is working to connect to my home Wi-Fi, so we'll give that a moment. It shows that it's connecting to the network. And we have an HTTP server is running at this address. So I'm going to copy that and open up Safari on my laptop. And I am going to paste the address at the top, and it will bring us to this page. This page displays the current temperature, the Hall value, and the red LED current state. Currently, the red LED on the board is on. Now, if we press red off, that should update the page to say red LED current state is off and the red LED on the ESP32 is off, just to show the output that we are receiving in the terminal shell. We see that we connected to Wi-Fi, the red LED turned off, and now we are going to turn it back on. This will then take a moment for the page it's currently trying to update. And here we can see that the red LED current state turned on. We have the LED turned on state here, and the LED on the board is on. So to wrap this up, in this demo we showed that we could connect to the internet, print out the IP address, go to that IP address, and in our browser, and it's pingable. It opens up this page. This page displays the current temperature, the Hall value, and the LED state. If we press any button, so this is a button and this is a button, it will update the page, as well as if we press red on, the red LED turns on. As we see, it's currently on. And if we press it red off, it turns off. Thank you.